All right, hey y'all, what's going on? What's going on? We got sound. Welcome to our Chemistry Live. Stoked to be here. My name is Brandon Piasecki. And today we're going to have some fun talking about some periodic table trends, how that connects with what we learned last week with ions and isotopes. It's going to be amazing. If you're just popping in, welcome, welcome, welcome. It's so good to see you all. So good to see you all. I am a science educator. I teach middle school science currently. I've had over a decade of teaching at the high school level with chemistry and advanced placement chemistry, all kinds of different chemistry classes. It's so much fun, and I'm so excited to be back in the chemistry teaching game with helping you master these concepts of chemistry to pass a T7 test. If you're taking the HESI, this will help you on that too. All right, but let's get into it, y'all. I'm really gonna jump kind of directly where I went from last week. Last week we were talking a lot about atoms, and we were doing some discussions about the atomic structure, the basic atomic structure, and also like some of the different types of basically atoms that can form. We have ions and isotopes. And so that's what we're going to talk about today. All right? I'm going to go more in detail with some of these concepts around ions and isotopes. Okay? Let's first start talking about this. I'm going to start with just some key points, some ideas, some notes. Let's get our chem on, Maria. That's what I'm talking about. I love that. So if you're taking notes, awesome. Write it down. If you are doing electronic notes, screenshots, annotations, all that fun stuff, this is the time to do that. And then we'll do some questions so I can check to make sure my concepts that I'm teaching are landing, okay? Let's do this, y'all. So an atom, just a quick review, is like the smallest building block in the universe, right? If the universe is a Lego set, the atoms are the Lego pieces. You cannot break them into smaller pieces at all. Now, atoms can take on different forms, okay? They can form ions and they can form isotopes. Okay, let's talk about ions first. An ion is an atom or molecule with an electrical charge due to the loss or gain of electrons. Ions can have either a positive charge. We call that a cation, okay? Remember, cats have paws. Cats have paws, so they're positive. Or a negative charge, an anion. Okay, remember, like, I'm anti, anti means you have a negative opinion about something. Anion, so that's why that's a way that I think about the difference between those two. Cations are positive, anions are negative. And then the reason why ions exist in the first place is because they have an unequal number of protons and electrons, okay? And this is a big thing. Ions form to help atoms achieve a stable electron configuration. We're going to unpack this a lot today. This is where the periodic table is going to become our best friend, the gift that keeps on giving, okay? And ions are typically represented with a symbol and a superscript showing the charge. So Na+, that's a sodium ion, a positive sodium ion. Mg2+, that's a magnesium ion with a 2+ charge. Okay? Sorry, let me just make sure I'm set up. All right. So first, let's look at what an ion looks like. Oh, I'm going to pause for a minute. What questions can I answer off the bat? And I'll leave this up for another like 10 seconds when he needs to get a screenshot or something. Welcome, Lisa. Welcome, everybody who's here. Had a lot of people just join in. We're doing a lesson today for our chemistry review. If you're taking the T7 test, we're talking about ions and isotopes and periodic trends. Okay, how the periodic table is going to be your best friend here. Okay. All right, here we go. Let's reset this simulation real quick and talk about it. So last week we were talking about atoms and how they form, right? An atom's going to have a nucleus, okay? The nucleus is the center of the atom, the core. It's got the neutrons and the protons in it, okay? And quick review, the neutrons help keep the nucleus stable. So as I'm adding protons, you can see like at a certain point the nucleus is unstable, but boom, stable again. We're good. We're good. Another quick review is as I add the protons, notice the name changes, right? So I added 3 protons, I'm at lithium. Okay, 4 protons, I'm at beryllium. Okay, 5 protons, I'm at boron. And we'll get to carbon. And I'm going to go up to oxygen, actually, for our little illustration here about ions. So oxygen, very common element, okay? We breathe it every time we take a breath. And the idea behind an ion is that, you see these charges here? In a regular atom, you're going to have a neutral charge, like a regular standard atom with no like alterations. Okay, just your basic atom. It's going to be a tie ball game. Okay, neutral charge means the charge is 0. Let me zoom in a little more so we can get a little closer here. Okay, now, and I will tell you, that's a great question. This website's amazing. It's got simulations for all kinds of stuff. I know there's other subjects that you need to know for nursing, and there's other simulations here. The website is FET. It's a free website. .colorado.edu. So here's the thing about electrons. Like, they're super important. Atoms by themselves, a neutral atom's not going to do much. The reason why atoms make connections with other atoms is because there's some kind of imbalance, and they're solving that imbalance and addressing that by making a bond. Chemistry really is all about, like, we have some sort of unstable pattern, and then we're reaching stability by a chemical reaction, right? Or some kind of process. And oxygen is going to form an ion, usually, because it wants to gain electrons. I like how this shows there's these nice little spaces. There's 6 of these electrons right here. We can fit 2 more here. Okay. Ooh, let's stay on there. So oxygen is going to, there it goes. Oxygen is going to want to add a couple extra electrons to become stable. This forms a negative ion. Okay, let's focus more on the definition right now. It's negative because it's got more electrons than it does protons. It's got 2 extra negative charges than it does positive charges. Okay. Last week we talked a little bit about, okay, how do I figure out what the charge is? Well, or how to figure out how many protons or electrons an atom has. The protons are always going to be equivalent to the atomic number. All right. So in this case, oxygen always will have 8 protons. Oxygen, that's like its defining characteristic. It has 8 protons. And if it's got a charge of -2, that means it's got to have 8 electrons to balance out those 8 positives with the protons, and then 2 extras. Okay. So this is a negative ion. And let's notice some patterns here. Oxygen's on the right-hand side of the periodic table. It's way over here on the right. And let's look at some other ions that could form, like lithium. Let's reset it. So lithium, if we look here, it has 1, 2, 3 protons. Just so we're accurate. Okay. Thanks for sharing that link, Maria. Super helpful. Extra credit. Now, lithium will usually form, I shouldn't say usually, it always. It always forms a positive ion. And it's over on the left-hand side of the periodic table. It's a positive ion because it has an ion that forms with lithium is going to be lithium with a positive 1 charge. It's positive 1 because it's got 1 extra proton, then it has electrons. Okay? And so today I'm going to go way more in depth about how do we know what the charge of an ion is going to be? How do we predict that? Okay? So the big pattern I hope we're seeing here is, okay, this is a positive ion, left-hand side of the periodic table, okay? And the negative ion we saw a minute ago with oxygen was on the right-hand side. All right? I'm going to pause this there. What questions can I answer? Ooh, who else taking the TEAS soon? Yeah. Sending all the good vibes your way. Okay, so we talked about ions a little bit. I'm going to come back to those. But I don't want to forget about isotopes for a minute. Okay? Let's move that. So, what is an isotope? Isotopes are variations of an element that have the same number of protons, but different numbers of neutrons. Okay? Mitch, yes, that is correct. And we're going to talk more about that and the why behind that. Okay? They have the same atomic number. Isotopes of an element have the same atomic number of protons, but they have a different mass number. Okay? The differing neutron count results in different mass numbers. They have the same chemical properties or similar chemical properties, and they may have some different physical properties like stability, which we talked about a little bit just now. All right? And this is what you might see when they're written out. They're written in one of two ways, with a dash and the mass number next to the name. So that is known as the mass number. They also might be written in this way, with the symbol and then the mass number written on the top right. Okay? So, let me go back to that simulation for a minute, and let's talk about isotopes now for a minute, and show the isotopes on the sim. Okay? So, a good example is carbon. Every single atom has isotopes, but carbon is a pretty common everyday atom that it's one of the main building blocks of life, right? So carbon, the most common form is going to be carbon-12. The reason why this is carbon-12, in the chat, can someone share why is this carbon-12? Looking at these here. Why is this carbon-12? Hey, y'all, welcome. If you're just joining in, welcome to our chemistry review session, y'all. Why is this carbon-12? It's carbon-12 because it has 12 particles in the nucleus. Okay? It's got 6 protons plus 6 neutrons. Yeah, there we go. Thank you for that. In the chat, we got it's the total number of neutrons and protons. Exactly. It's carbon-12. Now, look, if I add some more neutrons, watch this. Boom. I'm now at carbon-13. But it's still carbon. Like, I didn't change the identity of the atom. Okay? Unique, that is correct. Yes. It is it's carbon. This is carbon-13 because we're adding protons and neutrons. Let's move this down here. So to stamp it, atomic mass is equal to the number of protons plus the number of neutrons for any isotope. Okay? It's for any isotope or any atom. So let's go in the chat, sharing that encouragement out. Thank you so much. Thanks, Maria, for getting that conversation going. Y'all spread the good vibes to each other. That's a big part of this success, y'all, is community. So this, to come back to our example, is carbon-13 because it has an extra neutron. And there's also carbon-14 that exists. Carbon-14 is a good example of one that is not stable. So carbon-14 would be one of those examples of like, all right, so it's still carbon. It's still going to have a similar chemical reactivity of like it's got 6 electrons, but the nucleus isn't stable, okay? Unstable nucleus is going to be a cause for radioactivity, okay? It's radioactive. But carbon-12 is not. Like carbon-12 is the most common isotope of carbon. Carbon-14 is really rare because it's unstable. It doesn't stay like this for a long time, okay? So that's a quick discussion about and review of what isotopes are, but also a little more in depth about like, okay, we can have the same exact element. However, you can have different properties in different isotopes, okay? All right, welcome, y'all. If you just joined, welcome to our review on ions and isotopes and also going in depth on periodic trends on how we can use the periodic table to our advantage. Okay, I'm going to pause real quick. Are there any questions coming up for folks that I can address? Okay. Okay. Get some overlap in biology. I like that. I like that. Okay. So let's just really quickly compare ions and isotopes to neutral atoms. Okay. So neutral atoms, that's like kind of basic level, entry level in terms of like understanding what the atom's all about. You don't really see neutral atoms in nature, okay? And that's why we got to learn about ions and isotopes. Neutral atoms have an equal number of protons and electrons, resulting in no charge. And if there was no charge in atoms in the universe, like nothing would happen. There would be no, or relatively little reactivity that would happen, okay? Now, ions differ from neutral atoms because they have either more or fewer electrons, which causes a charge. And that is what's going to prompt ions to react and form chemical reactions, okay? So ions, it's a change of electrons, aka charge. Isotopes differ from neutral atoms because they have different numbers of neutrons. So isotopes change numbers of neutrons, which is a change in the mass. So this is like my big, like, write this down, screenshot it for the concept behind the difference, like just stamping like on a like the definitions of the difference between the two. I'm gonna give about 10 more seconds to get these notes written down, annotated, screenshotted, saved. Steph, you got this. you were in the right place. That's what I'm talking about. And everyone, if you are just joining, welcome. My name is Brandon Piasecki. I am a science instructor in my 15th year as being a science educator. I have over a decade of experience teaching chemistry in the classroom and a couple years working with nurses. I've been working with on their content and also doing lives. I think I just hit the 1 year mark not too long ago doing lives. So really love being a part of this community. It's so fun. So this is one of the parts of chemistry I really like. Like, I'm all about patterns. I really enjoy a good trend, a good pattern, recognizing, kind of understanding like why things happen. So earlier I gave an example of oxygen, okay? Oh, thanks so much, Maria. You're awesome. So earlier I gave an example of oxygen being a -2 charge. And that's a really important piece for oxygen's chemistry, okay? Oxygen is very reactive. We might not think about it that much because, I mean, you breathe it in, right? It doesn't really do a whole lot. Like, when you breathe it, we don't feel like, but I mean, in reality, inside our bodies is doing so much, right? And as part of, being in the field of nursing, like, your oxygen levels are like a really important vital sign of human health, right? Especially like if you're out, working in like more of a high trauma situation, ER situation, right? Like, oxygen's a big deal. I'm not an expert on that, but I know oxygen's a big deal on that front. Now, the chemistry behind that is because oxygen is over here on the right-hand side of the periodic table. And the way I've always described to students that I felt has worked best is the periodic table is like a board game, y'all. Okay? And oxygen's like right here, and it's in the situation where it's like actually really close to the goal of the board game. Now, board game analogy, this is kind of like, this is the target, kind of like in Chutes and Ladders, right? There's different ways to get around the board. You can take a ladder down, is a ladder up or a chute down, right? A slide down. So oxygen's right here, and it's close to the goal, to the end. This is like the finish line. This is a special group known as the noble gases. The reason why they're called the noble gases is because they don't react with anything. As in, like, their nobility. They're too good for all the other elements. They don't react because they have what's called a full octet. I'm going to throw a few terms, some good terms your way. Okay? The first is octet. Write this down. An octet is a full outer shell of electrons. And the magic number is 8. 8 electrons to be exact. Okay? Don't forget this phrase. 8 is great. 8 is great. That's an atom's motto. They always want to get that 8 outer shell of electrons. Oxygen's here. It needs 2 more electrons to get 8 in its outer shell, to get to the end. Okay? And the way I know that it is 8 is because if you count across, we always skip all these here when we're thinking of the outer shell. Okay? But it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Oxygen's 2 spaces away. Okay? So, oxygen is going to gain 2 electrons. Now, if we go over here, say magnesium. So oxygen's kind of, in the chutes and ladders analogy, oxygen's taking a ladder to the end. Now magnesium wants to get over here too. What's going to be easier for magnesium to get all the way here? Is it going to be to gain 6, 1, 2, 3, 4, 5, 6, or to lose 2? It's going to want to lose 2. It's easier. It loses 2 electrons, and it goes back like 1, and then it's going to end up in the same place oxygen would end up. Okay? Oh my goodness. That's an incredible rhyme. 8 is great. The odd test surprise. Atoms will share, steal, or ionize. That's 100% what happens. Love that. I used to write raps for my chemistry students, like in class. It's a lot of fun. Love that. That makes me smile. Okay. So that's the big idea here, right? We got magnesium, and you'll notice there's a pattern for this. This is just 2 examples, but the pattern I'm going to show you now is in groups 1, 2, and 3. I'm actually going to stamp my groups for a minute, okay? These are main groups 1 and 2. And these are main groups 3 through 8. So that's going to be a positive 1 charge because they're going to lose electrons. Yeah, magnesium's atomic number 12. Yep, Mg, magnesium, Mitch. Yep, good question. Okay. And these are going to lose 1. Okay. Those are positive 2. They lose 2 electrons. Okay? By the way, E minus is a symbol for electron. And then we're not going to worry about those. I'm just going to be honest. Like, this is not going to come up in a lot of the stuff you're going to experience, or I should say any that I've seen. And in general, we don't deal with these we call these transition metals. They don't follow the same patterns. But as far as today goes, we're only going to focus on this. And as far as the TEAS goes, you're not going to need to worry about that. So this is going to be a positive 3. Okay? Now, when you get to 4, this is, right here, these are a little bit of an exception to this rule. They don't form ions. They are going to form covalent bonds. Okay? These are going to form only covalent bonds, and they're not really going to ionize. Okay? Yep, left, lose, right, receive. Love that. Love that. Yep. So you got positive 3. So they're going to lose 3 electrons. Okay? We're not going to worry about group 14. But we are going to start getting into the same pattern, but on the opposite side. So it's going to be group 15 is now like over the hump, right? Now we're going to gain 3 to get to that octet. 8 is great. Gain 3. Gain 2. And then group 17 is, main group 7, excuse me. It's gain 1. All right. Left, lose, right, receive. I'm going to write that up here as well. Left, lose, write, receive. Okay? Pause for questions. They're coming up for folks. Now, here's my study tip for you all. Okay? The study tip here is don't memorize the whole periodic table, because in the chat, people always ask me, do I need to memorize the periodic table? Because I know you don't get one on the test. I would memorize what I'm going to outline here. There are some elements that come up more frequently, and I'll be also honest, I think that as long as you're practicing, you're going to be able to learn a lot of these with the studying that you do. So I would memorize just groups 1 and 2. And then not even all the main group, but part of the main group. Like, actually, I would do the noble gases as well. And I would say even like these are probably not as high priority, but I'll throw them in. This is what I would really focus on, like these and then like these parts of the main area right here. Okay, it's a whole lot less than the whole thing, but these are the ones I would start to recognize. It's, okay, this is group 1, group 2, main group 3, main group 4, main group 5, main group 6, main group 7, and then the noble gases, main group 8. Okay. Pausing again. What questions are coming up for folks? All right, let's keep going, y'all. Oh, no. You didn't see anything. Okay, this is a quick question. We're going to get into some questions now, y'all. So when we get to these, go ahead and throw your answer in the chat, y'all. In the chat. All right? Which of the following best describes an ion? What are we thinking, y'all? Awesome, y'all. Okay. So if we're thinking about these answer choices, like, let's go down one by one. So we know an ion, we talk about ions are atoms that have a charge. Okay? Atoms with a charge. And if an atom has a charge, then it's going to have a different number of protons and electrons. Oh, awesome. Thanks for sending that out. That's amazing. Welcome, y'all. If you're just joining, we'll do some just review here. So that's going to be A, as you saw. I think I might need to check some other questions and I might need to like reset these. Okay, because I have these questions in previous lives. Okay, but the teaching is always a little bit different, a little bit more nuanced. Now, if you're talking about different numbers of neutrons and electrons, that doesn't really apply much, but different numbers of neutrons and protons, that's going to be a isotope. Let me take some time real quick, y'all, to just reset some of these. back at it. Okay, here we go. So let's do some more questions. Here we go. Which of the following is a characteristic of an isotope? Different numbers of electrons and protons, different numbers of neutrons and protons. Always has a positive or negative charge, or the same mass number as other atoms of the same element. What are we thinking, y'all? What are we thinking? Love the collaboration here and the shares that are happening, y'all. That's awesome, helping out your fellow future nurses. Love that. Okay. Awesome, y'all. Yes, if you said B, that is correct. Stamping the definition of isotopes is a different number of neutrons than protons. Well done. Yeah, I'm going to go back at the end of each live. I always go back and stamp the big ideas one last time, go over the notes like briefly real quick, so you can hang for that. If y'all are just joining in, don't worry. I'm going to go back over just kind of to review the big ideas. Okay. What charge is oxygen if it has 10 electrons? And there's a periodic table there that you can use as we review and practice to hopefully help that internalize a little bit. This topic is ions and isotopes. In the chat, someone asked about the topic. This is ions and isotopes. With a little bit of periodic trends. Okay, got you. Okay, in the chat, what are we thinking, y'all? What are we thinking? Got a lot of responses. Love it. Keep it up. Let's give another 10 seconds or so. Now, what I love here is I don't see anybody who picks C or D. Okay, we know it's going to be a 2. The question is it a positive 2 or is it a negative 2? Well, let's see. If we think about oxygen, this is like a model after the simulation I was doing earlier. Okay, it's got 8 protons, 8 neutrons if it's stable. And it's got 2 electrons in this first shell, but it says 10 electrons, right? So if we're adding all the electrons in, that's 10 electrons. Then I got 8 positives in the protons, right? Protons are positive protons. Electrons are negative. So I'm going to say, all right, like 8 positives, 10 negatives. My overall charge is a -2. Visually counting them out. 8 positives, 10 negatives, right? And that's where that -2 comes from. There's 2 extra negative charges, okay? And earlier, if you were here earlier, and remember, like on the right-hand side, oxygen's on the right, it's going to be negative, right? Basically from here, from this group where it says 15, main group 5, over is going to be a negative charge, okay? Good job, y'all. Just do another one. All right, zooming in. An atom has 17 protons, and 18 electrons. What is the correct notation for this ion? I'll talk about what I had there in a minute, but not to distract. That's right. Keep those answers coming, y'all. Keep it up, keep it up, keep it up. Thank you for sharing this live out, y'all. Look, that's great. That's great. Love it. Got a lot of answers coming in the chat. Keep it up, y'all. Love the engagement. Let's give it like 5 seconds. All right. So let's think about this for a minute. 70 protons, 18 electrons. What you could do here is, like on the test, remember proton is positive, right? So that's positive 17. Electrons are negative. So that's going to be minus 18. Okay. Quick math, that's negative 1, right? 70 minus 18 is negative 1. So that means, and I didn't talk about this a lot. So props to y'all. If you said B, you are correct because it's the only one that has a negative charge. But if there's no number, it means that it's a negative 1. And I realized I didn't mention this earlier. Maybe I did briefly, but it was very like an afterthought. So to really clearly stamp this is one of those things. It's like a little funky chemistry quirk. For some reason, we don't put a 1 if it's a negative 1 or a positive 1. You know, in order to find the charge, they have to, if it's phrased like this, if the question is like, what's the correct notation for the ion or what's the actual charge, you have to be able to figure out the electrons. And in this case, usually they're going to give that to you. Okay? Yeah. Now, sometimes, if you're asked about like predicting, we'll talk about that more. I went over that a little bit already, but let's get to some questions that deal with that. And I can show you some strategies for that. Okay? So, no number means a value of 1. Okay? Okay. But we can't figure out isotopes. Let's talk about isotopes. Yeah, so the question also addressed neutrons. Neutrons will be that's where isotopes come in, okay? Because neutrons contribute to the atomic mass. Which is always true about isotopes of an element. They have different numbers of electrons, different atomic numbers, they have different numbers of neutrons, and they were always radioactive. What's the best choice here? Ooh, I'll go back because there was a question, like why not positive? I see that question. We'll go back and talk about it. All right, let's keep the answers coming on this one, y'all. All right, let's go answer by answer. They have different numbers of electrons. That is something we talked about. But is choice A isotopes or something else? What's choice A? How can we define that? Yep. Great job. Yes, this is ions, right? Can't be right for this question. Different atomic numbers? No. Last week we talked about atomic number being like the fingerprint of the atom. It gives the atom its identity. So you can't change that or it's a whole different atom. So it can't be that. It's going to be C. They have different numbers of neutrons. That is isotopes. That is a definition of an isotope. Now, isotopes can be radioactive, but they are not always radioactive. All right. Awesome, y'all. Okay. So, if an atom has 11 protons, 11 electrons, and 12 neutrons, what is its atomic number? And is it an isotope or an ion? So on the last question, C was talking about how it had different numbers of neutrons. Oh, and I didn't mean to go back to the previous question about why I wasn't positive. I forgot about that. So sorry about that. But let's start with this one first. Okay. Is it going to be an isotope or an ion? And what is its atomic number? Let's think about it. Nick, I see your question. Okay. All right, y'all. Yeah, let's talk about it. So remember, the atomic number equals the number of protons. And this is not something we talked a ton about today. It is a little bit of a review here. Atomic number is always the number of protons. So that's the atomic number for every element. It's always going to be number of protons. Now, because it says it has 11 protons, the atomic number must be 11. So it's going to be one of these. So now I'm thinking, is it an isotope or is it an ion? Well, if it were an isotope, it would have the same number of, it would have protons and like a different number of neutrons. If it were an ion, it would have a different number of protons and electrons. Now, this has 11 protons and 11 electrons, which means it cannot be an ion. Okay? So it can't be B or D because the atomic number is not 12. The atomic number is 11. And it can't be C because it's not an ion. So therefore, it must be an isotope. Oh, Nick, I see the correction. You got it. Good job. That's how we learn. You did great. And then look, there was some questions about previous questions. So let me just go back a couple here, okay? So just to stamp this one, isotopes, this is the true statement because isotopes have different numbers of neutrons. Okay. And then in this one, it's given to us that it has 17 protons and 18 electrons, right? So it's negative because there's more negative electrons than there are positive protons. You got 70 positives and 18 negatives. So that means an overall -1. The negatives are winning by 1. Okay? That's right, that's right. Yeah, eliminate down. Process elimination is a great strategy. Okay? All right, let's do another one here, y'all. This is getting into predicting what kind of atom or ion calcium will form. So I am going to leave this periodic table here as a tool because it's, we're still learning, we're still practicing. Calcium's right here. So this is what I was talking a lot about with, okay, group 1, group 2, and main group 3, main group 4, main group 5, all that. So see if y'all can remember, I already got answers coming. Shout out to you all for already answering. Which type of ion will form? And this is a good example of a question where, they don't give you the number of electrons and protons. And that's where memorizing, again, like the outline part of the periodic table that I have here is really important. I think I also included this in the last time I outlined it. These aren't as important, but like these are like, if you memorize all this, you're going to be just fine. Let's talk about it in 5. Talk about it in 4. Talk about it in 3, 2, and 1. Y'all are crushing it, y'all. I love this. Okay. I had a question in the chat about, could they ever give you the same number of protons and different number of electrons? Yeah, like that's an ion, right? That's going to be an ion. So last answer was 11 protons and isotope. Okay, here we go on this one. If you said that it is Ca2+, because it loses 2 electrons, then that is correct. Remember, if you are on the left-hand side, left, lose, right, receive. Thanks, shout out to Maria for that great little alliteration. Left, lose, right, receive. We're on the left-hand side here, so we're going to lose 2. It's like Chutes and Ladders. I want to get to the end of the board game, and it's easier to lose 2, lose 1, and then 1 more than it is to gain 1, 2, 3, 4, 5, 6. Remember, we skip all the ones in the middle. Okay? So a lot of you got, like most of us were on that. Like, that's great. So great. And if you were just joined, I did give a nice visual earlier of what this looks like. So we're in the lose 2 category here. Positive 2 charge because we're losing 2 electrons. Okay, 1, 2, and now we're in the noble gas situation. Okay? And right gain. I always said left lose, right gain. Right receive is another. I think that's a even better way to say it. In my class, I always said left lose, right gain. Okay. Let's talk about this one next. How many neutrons are in the isotope? This one, C14. I'll say it like that. Okay? Great conversation in the chat going on. Love this. Love the aha moments. Let's see if you remember what this one is, y'all. C14. So how many neutrons would be in that? How many neutrons are going to be in that? Great question. What is the atomic number? Okay, I will tell you. This is why, again, this is like one of the more common elements. Carbon is the atomic number of 6. Carbon is 6. Right there. With that said, maybe that influences your answer a little bit. I'm going to give another like 30 seconds. Okay? That's carbon's atomic number right there. It's atomic number 6. And I'm going to leave it right here so you can still see it. All right? Someone said now it's... Yep. So that might help. And this is where, again, it's like there's don't memorize everything. Don't like be inefficient with your time. However, there still is definitely value in memorizing some of the periodic table. Okay. Yes. If you're gonna, when I say, let me be even more clear. Yeah, that's a great question, a clarifying question. Of the section I outlined, I would memorize atomic number and atomic mass. I would memorize atomic number, symbol and name. Okay? And let's go over this real quick. C14. Now, that 14 is its mass. Okay? So it's a mass of 14. Okay? And if it's a mass of 14, and I know the atomic number is 6. Wait, hang on. In the chat, what do we say? Oh, let's go. Congratulations. I love that. So mass of 14 means we got 14. And to figure out, remember, like the whole equation I gave at the beginning was the mass is equal to the number of protons plus the number of neutrons. Which means that if we think about how do you find this number if you have 14 and you have the number of protons, it's like 6 plus what is 14? Oh, that's like saying I could just do 14 minus 6 to solve for that. Okay? So it's 8. Okay? Yeah, and so that you could memorize the different ways to find the different things, and or just remember, like, if I know 2 out of the 3, I can always find the missing piece. Okay? Okay. It's 5 o'clock. Let's close with one last quick question. Okay? Just to stamp what we learned today. Which of the following is true about ions and isotopes? Congrats in the chat. That's amazing. Keep it up, y'all. Ions have a different number of neutrons than a neutral atom. Isotopes have a different number of electrons than a neutral atom. Ions have the same number of protons as a neutral atom, or isotopes have a different atomic number than a neutral atom. What's a true statement here? The question should be phrased about ions or isotopes, not and. Got answers coming in. Let's go, let's go, let's go. Let's go, let's go, let's go. We got this, y'all. So, thinking about different numbers of neutrons in a neutral atom, that's not an ion. That's going to be an isotope. So it can't be A. And having a different number of electrons than a neutral atom, that's not an isotope, that's an ion. So it can't be B. And ions have the same number of protons as a neutral atom. That is true. Okay? Because, protons aren't changing. Whether it's a neutral Cl or a Cl minus, they're each Cl. And then isotopes have a different atomic number than neutral atom. That can't be true. Because then that would be a whole different atom. So yes, the answer, if you said C, you are correct. Good. All right, y'all. Thank you so much for being here. If you got here late, today we talked a lot about isotopes and ions. And just real quickly going over like the big ideas. Okay, remember that ions differ from neutral atoms by having either fewer or more electrons, which results in a charge. Okay? And hey, shout out to Maria for all the tips. Thank you, Maria, for all those clever memorization techniques. Thank you for being here and helping with that. And then isotopes, real quick, those are change of neutrons, change in mass. All right? We also talked a lot about this. This is a big one. Predicting the charge. Losing electrons, group 1. Positive charge, group 2, also losing electrons, positive 2. Okay? Positive 3 in group 3, main group 3. Main group 4, we don't really see any ions forming, but main group 5, we do start seeing ions form, but they're going to gain 3 electrons. Gain 2, gain 1. Awesome. Of course. And good luck to everyone on those exams, y'all. All right, everyone. I will see you next week. Same time, same place. Have an amazing week, y'all. And I can't wait to hear about all the success from all of the tests coming up in the near future. Keep it up, y'all. The next study session for Nurse Hub itself, in the chat, someone in Nurse Hub maybe throw out the next live that's coming up. I think there's another one tonight. I think. And chemistry is this one is every Monday. Same time, same place. I'm here every Monday, 7 p.m. Eastern time. Same time, same place. All right, y'all. It's been a great session. See you next week.